So if we see the Indian dairy sector, which contributes to more than 200 crore tons of the milk a year, and if we see that the total livestock sector is having around 7 crore livestock farmers who rear around 330 crore cow or buffalo. So if we take that, if we consider, because our whole dairy sector is highly unorganized. So if we consider the average, so on an average 4 to 5 cow or buffalo is maintained by each farmer. And if we go with the statistics of prevalence of subclinical mastitis in cow and buffalo altogether, so it's around 60 to 70% of the cow or buffalo is suffering from subclinical level of mastitis. And overall, because of mastitis, the theoretical calculation may be in the tune of 18 to 24 crores who suffer with the mastitis out of 30 crores of the animals. So there will be, it's all hidden because we are not getting income. If there is a decrease in productivity of the animal, so we are not getting any income. So we always consider that that's not a loss. But if we get such kind of productivity, higher productivity from if animals are healthy, then we may have higher productivity and we may gain 6,000 to 7,000 crores every year, which we are losing because of the mastitis. But the loss because of subclinical mastitis is 4 to 4.5 thousand crores. So this is an estimated figure that I am quoting from a literature. So why is such kind of problem still existing? I'm not mentioning here how much loss is because of mastitis in goats. Though still I have seen sporadic cases of mastitis in goats, but I have no data to share that what kind of prevalence of subclinical level of mastitis is there in goats. So how other infection takes place? It's mainly because of the unhygienic conditions, using milking machines and contaminated milker's hand. So all these are contributing to the spread of mastitis in animals. And I emphasize that intramammary infection, which we never talk about. We talk about subclinical and clinical mastitis, but we never talk about intramammary infection. So I will bring to the point because milk in the udder acts as a very good medium and source for bacterial infection, and that leads to intramammary infection. And milk is, during that period of time, milk is apparently normal and the disease-causing microbes start colonizing in the udder gland. So intramammary infection is characterized by rise in somatic cell counts. Somatic cell counts in cow and buffalo is inflamed, majorly the neutrophils, and less of the epithelial cells. So rise in the somatic cell count, presence of bacteria, that's the characteristic feature for the intramammary infection to exist. And intramammary infection will lead to subclinical mastitis if the animal is under stress or under the immunocompromised state because of the lactation of stress or environmental stress. So mastitis is caused by several pathogens, staph, streptococci, mycoplasma, klebsiella, enterococcus, lactobacilli, E. coli, and it leads to lowered milk production. Sometimes because of if there is a subclinical level of mastitis that remains there at the end of when the animal is drying off, then there may be loss of the function of water and complete udder gland. And sometimes because of the septicemia, there may be death of the animals. Or if there is a gangrenous mastitis that starts growing there. And from human health perspective, that's also very important because we are consuming the milk. Many a times raw milk is consumed, and sometimes we are processing the raw milk at home. So, and if the milk is having some kind of microbial contaminants, so that may that may be of genetic importance. The pathogens may be of genetic importance, and we may get such kind of severe infections. And many a times milk is offered to the kids. So for kids, it's very important for the health of and safety of that. When there is a high incidence of mastitis, then inadvertently antibiotics are used to treat that. And such antibiotics at a lower dose leads to spread of antimicrobial resistance, which is one of the biggest concern in present scenario that we may face in future. We may not face the problems or pandemic because of viruses or some kind of bacteria, but we may face a pandemic of antimicrobial resistant pathogens with lots of resistant pathogens. So antimicrobial resistance is a big concern nowadays, and mastitis is one of the reasons for which lots of antibiotics are used at a lower level, and that is also coming to the food chain. So if we consume antibiotics at a very small doses, in our system also such kind of resistant pathogens may emerge. So from that, both from animal health perspective and from the human health perspective, mastitis is one of the important diseases that we should keep into the account, that how to manage it. If you go with the pathology of mastitis, where in the initial stage there is colonization of bacteria into the mammary gland, that stage is intramammary infection, and if that will lead to subclinical mastitis and ultimately to clinical stage of mastitis, where there is a evident signs of inflammation. So during subclinical mastitis, there is change in the composition of milk, and also there is a decrease in the milk yield. So quality as well as quantity of milk gets reduced. So quality of milk is very important. Many times we are not bothered for the quality of milk in India, because we just see that color and consistency of milk is good, so quality of milk is good. So many times such kind of milk we are consuming, and there is no proper regulatory processes to observe that the quality of milk is good or not. Even the somatic cell count, like if there is a very high somatic cell count in the milk, then such kind of milk gets lots of lipases and proteases are present because of the cells are there. So cells will rupture and these enzymes will come into the milk, and such kind of milk has very poor storage. Like if you are stored for a longer period of time, then such kind of milk will get putrefied. So higher somatic cell count is not at all a good character feature for long-term storage of the milk. Then if we see the production loss of, if there is a, when production loss starts from 100,000 cells, if the somatic cells are present in the cow and buffalo, and if with the progressive increase in the somatic cell count, milk yield also starts reducing. So it's very important to have a look at that how this, suppose this is the stage from 200,000, when 200,000 cells are present in per ml cells, if they are present in the milk, then we consider that this from here and above, whatever is the increasing number of cells, then we say that it's a clinical stage of mastitis, and with every doubling of every like if the somatic cells are doubling, the milk production is proportionally reducing. So if you want to have a constantly a good source of milk from the animals and they are producing good quality and quantity of milk, you have to keep a check on the somatic cell count that is coming into the milk. Right now in the field, California mastitis test is the only field applicable method that can detect because the sensitivity limit of sensitivity is best you can get at this point. And between 1,000, 100,000 and 200,000, if you want to detect mastitis at this level, subclinical level, then its sensitivity is only 60 to 70%. So this California mastitis test is good for detection of clinical stage of mastitis, but for subclinical mastitis, sensitivity is not very good. So at intramammary infection, when the somatic cell count is very less, like 25, 50,000 cells, so at that stage, CMT will definitely give a negative result. So it's not at all good for checking up the intramammary infection. So the need of the time is to detect such kind of to develop such kind of kit that can detect earlier stage of mastitis, so that you can have some interventions in place. So in the today's scenario, it's whatever we are detecting is just tip of the iceberg, where we just observe the clinical stage of mastitis, and we are not at all bothered about the subclinical stage of mastitis. So a person looking at the farm will only see only one cow or buffalo who is suffering from mastitis when he is just observed, when he is just bothered about the detection of clinical stage of mastitis. But if you have a proper detection system, then you will definitely get shocked and to see that so many animals have turned out to be subclinical level positive for mastitis. And this is the truth. I have also witnessed while going to several farms, and maybe a few of the doctors who are attending this webinar they are also, they will also share their experience that many farms, dairy farms, where you go and see lots of animals are positive for subclinical mastitis, even if the milk will appear normal, but the animal are suffering with subclinical level of mastitis, and people are not at all aware about such kind of situation. The diagnostic practices that currently what we are following is California mastitis test, then viscometric detection, where we discuss, where we check the viscosity. So these are the few standard methods that people have developed, and few of them has got translated also, and few of these are the methods that has been reported and patented and published. So on the basis of that, in future we can develop a better diagnostics. So even estimation of lactate in the milk, people have used for detection of mastitis, but lactate is not a very good marker for mastitis, because such lactate composition may change because of several other situations, in different situations. Microfluidic chamber-based assays have been also developed, but it will be definitely very expensive. And conductivity meters has been developed, and such kind of sensors are getting attention at the field level, but the conductivity may change because of some other reasons also. It's not only because of the somatic cell count. So it will not always give you the correct idea about the somatic cell count. Then detection of milk amyloids, infrared tomography, and a staph detection of a rapid kit for detection of staph infection. So few important ones. Now I will discuss one by one. So this is a video where phosomatic 7DC. This is a device that is used for somatic cell count. So this is a big device, but it's not field applicable ones. You can do at a very large organized farm. You can have such kind of machine where you can detect the somatic cell count by this, but it's very accurate. Then I will talk about a rapid staph detection kit. So this is a staph, because considering, if you consider that a staph infection is more common for mastitis, and you detect a staph infection in your herd, then but there are some other reasons also for mastitis. But this is a kit for detection of only a staph positive mastitis cases, where you can detect. But this kit is also not very. There is a published paper where people have suggested that out of 62 among the 62 other coagulase negative staphylococci, 4 were misidentified as epididymis, and 7 were misidentified as saprophyticus. So there is it's not a very specific test for even detection of staph, though it's available in the market, commercial market in the European world, but still the sensitivity is not very good. While the sensitivity and specificity of fluorogenic coagulase test for staph aureus were 100% good, but it failed to detect alkaline phosphatase activity in several epididymis isolates, resulted in a fewer correct identification by this test. So this is a published report that suggests that though it has some promises for coagulase positive staph aureus detection, but it's not very accurate for detection of alkaline phosphatase activity in these isolates. Then this is the conductivity measurement devices that has been commercialized, and here it measures the conductivity if there is more of the somatic cell count. So, but many a time the somatic cell count varies from breed to breed also, so that will give you the variation in the somatic cell count. So such kind of it may not give you the correct idea, and you require a lots of expertise. It will give some values that what is the conductivity. If you are regularly monitoring, you may observe that if you are regular monitoring the animal with this device, then you will definitely come to know that from the past, now what's the status of the conductivity of the milk. So in that situation, it will be definitely useful for the farmers to have a track that whether the animal is developing some kind of mastitis or not at subclinical level also. So this kind of device is now becoming popular and it's being used in the organized dairy sector. Then the viscosity, there is a device that has come up in Russian market, which measures the viscosity of the milk. And on the basis of that, they say that whether it's going to have mastitis or not. So on the basis of viscosity, I'm not aware about availability of this machine in Indian market. Then there is also a somatic cell counter. It's a sensor-based device that detects the somatic cell count. So it does. It is especially convenient to use during controlled milking because analysis of one sample takes very less time. In minutes, it can be done, and it's the device doesn't require any preliminary sample preparation before analysis and doesn't use any chemical in the analysis. So this is also a good device that can be used for counting the somatic cells. But definitely the device will be costly, and that's the reason because in Indian market for Indian farmers, we require some kind of test that's very inexpensive and that can be very easily that's very easily available in the local market. That's also has to be ensured that the kits are available in the local market and it should be easy to operate. So these are the few things that has been developed by other laboratories or other companies. What we have done, I will talk about what we have done at NIAB for diagnosis and treatment of the mastitis. Why I'm talking this? Because in whatever I discussed before, all the 3-4 methods for detection of mastitis, this test will tell you that what is the status of the animal, like whether they are having mastitis or not, they are infected or not, whether they require some kind of treatment or not. But the veterinarians always face a problem which antibiotic to be prescribed in a specific cases. And many a times, the paravets who work in the field, whatever they have, they will start giving such kind of antibiotic treatments, and it takes long time and bigs up the huge loss for the farmer and also huge suffering for the animals if they are not getting the proper antibiotics. So in the present scenario, there is no such field operative methods for application of antibiotics. No, there is no choice. So you go with your experiences and you go with whatever you experience and whatever is the broad spectrum antibiotic that is available with you, and you go for the treatment and you can try, or on the basis of your expertise that in this series and which kind of and they are sensitive to which antibiotic. So it's a very it depends on the some way out that we should be able to through which we can detect through which we can identify which a specific antibiotic to be given to the in particular case of mastitis. So we have come up with both. We have come up with a very affordable method and easy to perform this method for detection of very early stage of mastitis and also for the treatment of mastitis. So I will take you through that what we have developed. So in this, it's a 3-step process where you take milk in a tube and add iron nanoparticles, and then you mix and wait for 5 minutes, and then you add a surfactant, and after that you have to pour onto a disc. So this is a device where if you pour the solution onto this, then if there is such kind of where there is formation of aggregates onto the membrane, then there will be that gives an indication that there is higher level of somatic cell count in the milk. And if there is no such aggregate formation, that means the milk is very good. There is no somatic cell count presence of very less amount of somatic. It's a very less amount of somatic cell, and need not to worry about that. So it's a very affordable and cost-effective solution for mastitis, and it requires, like, if you are using like if will be coming around less than 20 rupees, like 10 to 20 rupees, it will be a cost. And we are in the process of automating the process. The prototype we have developed is a manual one, but we are working for developing a automated system where you have to just put the milk and you forget about after 10 minutes, you will get the result. So we are working for such kind of solutions in near future. It requires less than 10 minutes time. And the good thing is with this method, like as compared to California mastitis test, where you have just a visual idea that what's the extent of the mastitis. Since this whole aggregate, the iron nanoparticle aggregates, is on the piece of paper, so such kind of paper can be kept as a visiting card. As a visiting card, you can keep, and you can see that aggregates are present or not. So that gives you a reference that what was the status of aggregate formation on 0 day of treatment and after 5 days of treatment. So that gives you an idea that whether your treatment, whether your animal is responding for the antibiotic treatment or not. So it will give you a very fair idea that how your animals are responding, how treatment is going, and how much time it will take for the animal to get cured. So I will share a video here so to get an idea how it is performed, how the test is performed. So you see here, if there is formation of aggregate on the membrane, then it's positive for mastitis and negative for this where there is no aggregate formation. So it's a negative for mastitis. Now, since obvious question will arise that if you have here, you see 2 big clumps. In another case, you will see 5 big clumps. So which one is having higher and lower? Many a time making a judgment will get difficult. So what to avoid to make it easy for person to understand that what's the number of somatic cells present here, and in other case, what will be the number of somatic cells. So I will show you how we have come up with the solution that we have developed a mobile application where we have used artificial intelligence to train that software, and that gives a correct idea, nearly correct idea, like that how many somatic cells are present in that milk sample per ml of the milk sample. So such kind of things we have done, and I will show you that data also in the coming slides. Now, second thing that I told you that what to do if like you have diagnosed the animals that it's a positive for mastitis, then what to do? In that case, which antibiotic to be given? So we have a pre-coated it here, it's 5, but just for the sake of understanding, but we have 8 wells where we have coated these wells with different antibiotics. What you have to do is you have to just add the milk, and we have devised a incubator device where temperature is maintained at 37 degrees centigrade. So what you have to do is you have to just pour milk and then incubate it for 2 to 6 hours and observe the change in color. If the color is maintained like blue, then such antibiotics are very good for treatment. And if the color changes to pink, then such antibiotics need not to be prescribed. So that within 2 to 6 hours, you will get an idea at field level. You just require a plug-in system for power, where you maintain this is a very small power. Power is requirement is also very small for this. So no laboratory setup is required. Normally for this, if you require a microbiology lab, and it will take at least 1 to 2 days to come to the result. So here we have for the ease of the farmers and field veterinarian, we have this device that can be used very well in the field condition, where you can very easily perform this test, and within 2 to 6 hours you can identify which antibiotic to be given. So initially it will appear blue, and then you have to put into the incubator box. So incubator box will, if you switch on, it will maintain the temperature at 37 degrees. Wait for 2 to 6 hours. Then you will see the observer change in color. So in this case, these two antibiotics should not be used. You have to use only the antibiotic in the first well. So on the basis of this, you can select which antibiotic to be given. So this is a very simple assay that we have developed for selection of antibiotics. Now to test whether whatever we have developed is fine. So we went to a dairy farm near Hyderabad, outside on the outskirts of Hyderabad, and then we checked these are the gill cow there. They maintain a very big farm of gill cow. So, and we checked these animals for mastitis. They randomly we took some animals, and using that mastitis our kit, we checked them whether they are positive or negative for mastitis, and we also performed on farm on the field itself. We performed this assay for selection of antibiotics. On the basis of that, I prescribed antibiotics and supportive treatment to them. And after that, see the result. So after again we went to, so after 5 days of treatment, the mastitis detection test was repeated in the same animal. So suppose for animal ID 12, the aggregation test was like this. So it's a very extensive aggregate formation, and after 5 days of treatment with enrofloxacin, see the result. So there is a clear-cut decrease in the somatic cell count in all the animals. Now you will observe, you will see that in these two animals, why there is an increase in the aggregate formation. The reason is the farm manager did something wrong, and he forgot to give antibiotic to these two animals. And that was the reason. So sometimes it happens for good for us, because we wanted to see if you don't give the antibiotic, you don't know how the disease will progress. And this is it's a clear-cut indication that how the disease will progress if you don't give antibiotic to the animals, and if you treat with the right antibiotics. And the right antibiotics are prescribed by using the antimicrobial sensitivity test developed by us. So it gave us very good confidence that such kind of this test has merit to detect antibiotic, and we can also treat on the field. No need to go to any kind of diagnostic laboratory. So as I mentioned earlier, that we have developed a mobile application. So for that, it took a long time for us to understand how to deal with the software and the programming languages. And now we have a mobile application ready with us where you have to scan the image in the first step, then a scanned image you have to upload, and then you will get the concentration of the number of cells. So it will display the number of cells over here, and also it for a layman or some layman person to understand what's the level of if the number of somatic cells is this, then what will be the level of infection. So it will tell that whether it requires treatment or not. So it will appear like this. So if there is no aggregate formation, it will show the number of cells 0, and there is no bacteria present in this case. So, and if there is a subclinical level of mastitis, then it will show like this. So software works like this, and we also check the growth of microbes in this milk isolates. So if you see this just for sake of better understanding, so after performing those milk aggregation assays, you put the aggregate onto a membrane cassette where you will be able to visualize formation of aggregates. Then with the help of mobile application, you have to scan the image, and then scanned image you have to upload, and then you will get a notification that the somatic cell count is less or more. On the basis of that, you can take a decision you have to go for the antibiotic sensitivity test or not. That was all about what we have developed and people have developed in mastitis. Now, few things I would like to bring to everybody's notice that is somatic cell count a good indicator for mastitis in goat as well as we do for the cow. So somatic cell count has been accepted as a quantitative index for mastitis conditions in cow milk or for degree of glandular irritation in bovine mammary gland. However, there has been considerable controversy on somatic cell count in goats. So average somatic cell count in goat milk is 750,000 to 5.4 million cells per ml, and which is and such kind of range you will observe in cow when there is a clear-cut clinical case of mastitis. So the basal level of somatic cell count in goat milk is higher than cow. So same test can't be used for goat milk. If you are using some kind of cutoff for a standard for goat milk. So for that we require some kind of optimizations. The reason for why there is a difference that goat milk is having higher somatic cell count, and even at the basal level, even then there is no reason why there is a higher somatic cell count. So I will bring that to why such kind of difference is there. So it's a difference in the physiology of milk secretion in cow and buffalo and in goats. So it's basically the secretion of milk from the mammary gland is merocrine secretion, and in goat it's apocrine secretion. So the milk droplets that is formed is getting released in the form of droplets. However, in the case of goat milk, because when there is a trafficking of the vesicles endoplasmic from Golgi apparatus to endoplasmic reticulum, it's a defective because they are deficient of beta S1 casein protein, and because of that reason, it gets pinched off with the cell membrane, and you observe a defective. There is no DNA in this. There is a cell membrane, but there is no DNA. It has the vesicle. So lots of particulate matter comes into the milk. This is not a cell; it's a defective cell, and that gives a false impression that you observe a lot of cells into the milk. Now we use the term exosome. So we use the term exosomes in goat. For more, we say that goat milk is rich in exosomes because they are not somatic cells, actually the somatic cells. And we also know that goat milk is rich in nutrients. Then there are some unknown factors. Because of that, people get healed if someone is diseased, right? So because of why there is such a difference between cow and goat milk. So this is my assumption that since when these vesicles are getting pinched off from the cell, so such kind of vesicles carry lots of cytoplasmic content, cell cytoplasmic content, where it has lots of metabolites as well as RNA or microRNA or something, and such kind of things comes also into the milk. However, in cow milk, such kind of phenomenon is not happening. So cow milk is devoid of cellular metabolites and other factors that comes in goat milk, and maybe that's the reason why goat milk is so powerful and so much of engaged with the several factors that gives lots of nutrition to us. And when the person is immunocompromised, then it gives immune boosting or many other functions that we don't know what it does. So this is the reason for difference between the cow and goat milk. And goat milk, as I have mentioned, alpha S1 casein is deficient. Because of the deficiency of that casein protein, the process of this release of the casein protein from the milk gland to from epithelial cells, glandular epithelial cells to the outside is defective because of the deficiency. And I have also read somewhere that if because alpha S1 casein is deficient in goat as on also in human, so it forms a very soft curd. And because of that, the digestibility of goat milk is very good as compared to cow milk. Cow milk forms in the stomach. If it goes, then it forms a very thick curd. The consistency is very high. That is not good for digestion. But human milk and goat milk forms a soft curd because of the deficiency of alpha S1 casein. So because of that reason, goat milk is far better than cow milk in terms of digestibility and the how much assimilation of the nutritive factors takes place. This is just again the same thing. These are the mammary epithelial cells, which is more in goat milk, but more neutrophils and other inflammatory cells you will find in cow milk if there is a mastitis. So to conclude this, whatever I have mentioned as a conclusion, bovine mastitis. For bovine mastitis, devices for measurement of electrical conductivity and somatic cell counts are the most promising ones, while for sheep and goat mastitis, field applicable test has to be worked out because of the difference in the somatic cell count, and because of the somatic cell count is different, there will be change in the conductivity as well, and also for detection of somatic cell count. So there is a need for optimization of the parameters for specifically for testing goat milk and sheep milk, and has to be validated with the mastitis cases of sheep and goat. So such kind of thing has to be worked out. So now we have the leads, we have the technologies to detect mastitis. Now it has to be applied in sheep and goat, and it's all because why it's not there in place. The reason is ignorance, and goat and sheep has not got proper attention in research that we have to worry about the mastitis in goat and sheep. So if in future maybe such kind of technologies will definitely come for goat and sheep mastitis as well. Also, the prevalence of sheep and goat mastitis is also not very well documented. That in future we need to do that. If we take a concerted effort, then such kind of data will also be available to discuss. So at the end, I would like to thank my all group. This is the research group that we have at NIAB. And I would like to thank the funding that we have received for research from Department of Biotechnology, Ministry of Science and Technology, NIAB, and BioRack, which is also a subsidiary of Department of Biotechnology. And thank you very much for your kind attention.